This next video covers graphing a linear inequality in the plane in standard form. This is the third video I have of graphing different types of linear inequalities in the plane. So if you haven't watched the other ones, you should really go back to build up to this. So linear inequalities with two variables can be written in any of the following four forms. The only thing that differs is what symbol is used, what inequality symbols. And make sure that a, b, and c are real numbers, and a and b are both not equal to 0. So when I graph a linear inequality, it looks a little bit different than a linear equation, because not only do I have to graph a line, I then have, or a dashed line, as we will see, I then need to shade one half of the plane, because our solution is all ordered pairs that satisfy the inequality, and there are a lot more when instead of just a linear inequality, a linear equation, I have an inequality where I have like half of the whole plane is my oyster. So we know when we graph a linear equation, it kind of divides my entire plane in half. We call each half the half plane, and you're gonna have to shade one of those when working with inequalities. So how do I graph a linear equation? So the first thing I would do is I would set take your inequality symbol and replace it with an equality sign and graph your line as you have before. Note that if it's a solid line, you must have a less than or equal to or greater than or equal to symbol, because that means your line is part of the solution. If you have a greater than or less than or greater than, use a dashed line, because that means your line is not part of the solution. Okay? Next, you need to choose a test point on one side of the half plane. I choose 0, 0 as long as I can, but you cannot choose a point on your line. And I substitute the test points into my inequality. If I get a true statement, then I shade the side that has the test point, because that test point is part of my solution. If I get a false, then I shade the opposite side, because that side with the test point was not part of the solution. One thing I want you to see is that, if I have y is greater than, you want to shade above the line. Y is less than, you shade below the line. But sometimes it's not like so clear, like in my opinion, which is above and which is below. So what I always recommend doing is the test point method, and that's what I'm going to do for these 3 examples with you guys today. So I have x minus 2y is less than 4. So first off, this is in standard form. So I don't know the slope, I don't know the y-intercept. I could go ahead and solve for y, and if I do so, that'll tell me my slope and my y-intercept. I divide both sides by -2. Remember, when I divide by a negative, I have to flip the symbol. So I have 1/2 x minus 2. So y is greater than 1/2 x minus 2. So here's my y-intercept. My slope's 1/2, so I go up 1 over 2, up 1 over 2, and it's strictly greater than, so this line is going to be dashed. Then I have to decide whether to shade above or below the plane. So I pick my test point, which is 0, 0, and I substitute it in. So I have 0 is greater than 1/2 times 0 minus 2. 0 is greater than -2. This is true. So that means my test point's part of my solution, and I'm going to shade above the line. So for our next example, we're going to need to do the same thing. I have 3x minus 2y is less than or equal to 4. I subtract 3x from both sides. -2y is less than or equal to -3x plus 4. I divide both sides by -2. That means I flip my sign. I have 3/2 x minus 2. So my y-intercept is -2. And now my slope is 3/2. So I go up 3 over 2, up 3 over 2. And this is going to be a solid line, because it's greater than or equal to. So we can graph our line. Now I need to decide which side to shade. I have no idea. So I pick my test point to be my origin, 0, 0, and I substitute that in to my equation. 0 is greater than 3 halves times 0 minus 2. 0 is greater than negative 2. That's true. So I'm going to shade the side that contains my test point. So I'm shading above. If you go over a little bit, that's an accident, and that's okay. Your teacher hopefully will be kind and understand. Beautiful. So the last example I have for you is 2x plus y is greater than 3. So I am going to go ahead and solve this for y. I subtract 2x from both sides. Y is greater than negative 2x plus 3. So 3 is my y-intercept. My slope is negative 2. But when I have a slope that's an integer, I put it over 1. So I know I'm going down 2 and to the right 1. So I go down 2 over 1, down 2 over 1, down 2 over 1, all of this. And I started to draw a solid line, but that's wrong. I see, okay, this is greater than, strictly greater than, so I need a dashed line. It's a good thing we can always erase, so we can go ahead and put a little dash line in there. And then I need to determine which side to shade, so I pick a test point. I have 0, 0 as my test point. I substitute that into my equation. I can substitute into the original or the new one. Let's substitute in the original. I have 2 times 0 plus 0 is greater than 3. That gives me 0 is greater than 3, which is false. So I'm not going to shade the side with the test point. I'm going to shade this other side. So let's go ahead. Make it a pretty green.